Hi, Rob.
Hi, Jen. Nice to meet.
Yeah,
Hey
nice to meet you.
everyone. So are we
Everyone.
ready? Are we ready?
Yeah, we're ready.
Okay. So let me do the intro first, and I'll let you guys talk. I'll start right now. Hello everyone. We are at another week of OpenGuild Community Call. Our live streaming call is brought to you by OpenGuild and Polkadot Insider. A little bit about OpenGuild. We are an open community connecting Web3 innovators dedicated to advancing the Polkadot ecosystem in Southeast Asia. So, yeah, join us on Discord and X to be a part of our growing community. So, today we are thrilled to have the incredible guest joining us today, Robert Habermeier. He is the co founder of Polkadot. And of course, we have Tin, our developer relations lead at OpenGuild. Hi, Robert and Tin. I am honored to welcome you to the show.
Hi, Pia. Hi, Rob. And it's a great, Saturday morning to have this conversation with the father of Polkadot. So, yeah.
It is. It's my pleasure as well. So welcome, Robert. How are you doing?
Oh, I'm pretty well. It's still Friday night here, so I'm in Texas. It's quite a time difference. Thank you for having me, and thank you for the warm welcome. Looking forward. I've seen some of you on social media. I don't think we've had the chance to meet in person yet, but happy to join and provide my perspective to the community.
I'm excited as well. It's great. So today is going to be more of a Q&A sessions, and our focus is going to be on NOM. As we all know, it's a truly advanced state database solution and designed to reimagine blockchain underlying storage. So it's interesting how here at Polkadot Insider at my side, we have also just finished like a YouTube video about NOM. So I am really excited to learn even more about NOM today from you guys. So, yeah, let's get right into our talk. And Robert, it's a pleasure to hear your sharing today, and I'll let Tin take over the space.
Yeah. Okay. Thank you, Pia. So, yeah, hello, Rob. So, in the last time you talked about NOM, you present about NOM. You did have a very amazing representation in Sub-Zero event, as I remember. So, how have you been doing since last event?
Well, let's see. We've made quite a lot of progress. It takes a lot to, and just for some background, at Sub-Zero in the beginning of November, I presented like the core ideas and some of the architecture and the vision behind NOMT, like why we're doing it, and I can go over any of that in this call as well. But just to give a little bit of a development update, during the presentation in Sub-Zero, I said we would announce and release version 1.0 by the end of the year. I think we're going to miss that by a little bit, but not by much. Software deadlines being what they are, and we are, we're rounding the final corners. We're in the final stretch of testing and of adding the very last finishing touches, and then preparing to write some documentation and then releasing it. After that, the focus will be on integrating it into blockchain stacks like Substrate and Polkadot SDK.
I see. Is NOM like the only thing that you're focusing on right now, or you have any other project?
That's the only thing I'm focusing on right now. So I left Parity. I was at Parity for 7 years. So from May 2016 to September of 2023, and I'm working with a small team of developers, some of whom I worked with previously at Parity, some of whom I worked with or got to know during the Polkadot Blockchain Academy. And we're just building NOMT. I think it's better to have one focus at a time and just do really good work on one thing.
The guy that you mentioned, like from Polkadot Blockchain Academy, he's Gabriel, right?
Yeah, Gabriella.
Yeah. Like he's also like one of the instructor in in like Polkadot Blockchain Academy Singapore cohort, and I learned from him a lot. Yeah, so he's a very friendly.
Awesome.
Yeah.
Yeah.
So in the last Sub-Zero event, how do you feel about that? And also, like, what is the response from the dot community for the innovation that you introduced?
Yeah, I thought it was a very good response. I really enjoyed the event. I mean, we've had Sub-Zero since 2018 after we first started to build Substrate. And for the past few years, there has been one team hosting Sub-Zeros, but actually this most recent Sub-Zero event was a new team, and they kind of brought a little bit of a more like fresh feel. They brought in artists to decorate the venue and create a more of a community and inclusive feeling there, which I really enjoyed. There was a lot of energy. There was a lot of stuff happening, like different talks by developers at Parity, but also a lot of talks by people who are just using Substrate as it should be. So I really enjoyed that. And I think people were pretty excited about NOMT and also, the vision that we were laying out, kind of trying to think a few steps ahead to where blockchain scaling is going to go.
I see. Yeah, 2018 and 2024, it's been like 6-7 years. So what's the difference compared to like the event back then?
So yeah, I mean, very different. Like what I remember of the first Sub-Zero was we had one room. It was a big room, and it was there were some food and drinks on one side, and there was a stage on the other side of the room, and a 2-day event. Actually, Anna from the Zero Knowledge podcast helped to organize a lot of it. That was before she switched to doing the podcast full time. And a lot of the talks were by Parity people who were, I mean, we didn't have many users because Substrate was still very, very heavily under development, but we had a lot of people who were interested in the technology. So I think one of the biggest changes is, it's been, Polkadot has been live and Substrate has been usable for, over 4 years now. Or almost, over 4 years. And that's a longer period of time than it was from the first Sub-Zero to the time that Polkadot launched. So during that time, there's been a lot of refinement, a lot of improvements, but also a lot of users. So I think this is a very important thing for, as technology evolves and people use it, that we now have that feedback, right? And I think there were many talks by like Ian, who I believe was on an OpenGuild session previously. He's really taking that feedback and using it to improve Substrate. And now I think it's more of a conversation, right, between the developers and the users and the builders who are using it than a presentation about like what the latest in Substrate is. And obviously the community has grown a lot since then.
Yeah, decentralization matters. So aside from like NOMT, like NOMT, you also like propose a major innovation, which is like Plaza. And I read your article that, like a very well-written article. And as you mentioned, like Kian, we also like did have a conversation with Kian 2 weeks ago about like Plaza. So I just wonder, like, what's the plan between like NOM and also like Plaza?
Yeah, I think that they go very well together. So, the idea of Plaza, which, Plaza was really more of a vision article about, the feeling, right, of creating a plaza, right? And a plaza is a town square. It's a place where there are merchants, people walk there, they go and look at the sites, they spend their day, they do whatever they have to do there. We turned more to calling this the Polkadot Hub in time. So making a distinction between the Polkadot Hub and the Polkadot Cloud. Polkadot Cloud being the broader services that Polkadot provides around like building your own blockchain or making use of the compute, and the hub being kind of the main place that you're going to go to do all of your activities. And I think this is the evolution of the Plaza concept. I wrote the article in June and now it's already December, so there's been a lot of time to really refine the messaging on that, and Sean has really pushed that. But the idea is that you know, Polkadot lets you, and from the beginning it was meant for to be a place where people could build their own blockchain and deploy there. And that has changed as well. Right? I thought first there would be 100 chains, so each chain would get one like of Polkadot's cores, like kind of like a CPU core on hardware. Each chain would get one core. Now we've looked at things like agile core time, which is live, where one chain can use multiple cores or less than a core. They can share cores with other chains and things like that, you know, to try to make it more fluid. But under the hood, like at some point, you always need to do horizontal scaling, right? That is just fighting. If you want to do only vertical scaling, you are fighting reality, right? Because there's only so much computation that you can do on a single machine or a single set of nodes. So we always want to have this kind of horizontal scaling where there's multiple nodes, or multiple chains. But in the you know, in the meantime, it's very good to have a single place, one chain, right? Because there's a lot of frictions when you're dealing with many chains. You have to find ways to transfer your tokens around. You have to, you know, move your chains, your tokens from one app to another. You have wallet addresses on all of these different chains. And even if you're not doing that on your own as a user, you know, your wallet needs to do it. The wallet developers need to figure it out. And the idea of the Polkadot Hub, I think, is to make this very easy user experience, that there's going to be one sort of flagship chain that's launched on Polkadot. That's going to be the Polkadot Hub. You'll be able to write smart contracts. It's much easier than building your own blockchain. You'll be able to, as a user, interact with all of the apps that live there. There's going to be a lot more liquidity there. There's going to be like lots of DeFi, right? Like all of these things that are currently fragmented, to really bring those together to create that town square. But of course, it has to be able to scale to the point where, you know, it doesn't become a bottleneck, at least for the foreseeable future. Now, I like to think about it in terms of urban planning. Like a city always grows out from the center. It's not like, you know, there people have tried this in the past. Right? They said, well, we're going to build a city. Well, we want to have this district be here. We want to have manufacturing is going to be here. We want people to live here, and we want people to go to their office building here. And when you start from the top like that, it never really works. So it's much better to have something like a neighborhood where like somebody decides they're going to use this building for this, somebody decides they're going to use this building to live in, to work in, to make their things. And anybody who's spent any time in cities knows that cities that work really well work exactly like this. And so that's kind of the high level vision for this hub.
Yeah, that's great too. So because you mentioned about the scalability of the Polkadot Hub, is like an NOMT, like norms, like one part of it that like gonna solve the scalability issues that you can serve like millions of users on the Polkadot Hub.
Yeah, I'll make things very concrete because I've spoken in a lot of metaphors up until now. So the idea of NOMT is how to make the best use of current hardware on a single chain. So when you build a chain, every node keeps a copy of all of the state. By state, I mean account balances, right? Which accounts, which tokens, which smart contracts exist, what storage is in those smart contracts. You name it, it's in that state. And they keep all of that for the chain. And this, keeping this data on an SSD, a solid state drive, is the bottleneck, right? So you have a space bottleneck. How much space can you keep? You know, how much space do you have to keep items? What are your node requirements? How many accounts can you store? Because if you can only store 1,000 accounts or 1 million accounts, then you can't serve 10 million users. You can only have 1 million users if you only have space for 1 million accounts. You don't want the state to get slower as more accounts come into it. But you also need to scale, and accessing data from the disk is very slow relative to accessing data from RAM. You know, computer takes maybe 40 nanoseconds to read a piece of information from the RAM, the random access memory. It takes 40 microseconds to read it from the SSD. And that sounds like a very short time, and indeed it is. But when you try to do tens of thousands of transactions in a second, that 40 microseconds starts to feel like an eternity. So our goal is to make things very concrete. A high-end solid state drive today is going to be about 4 terabytes. It's going to cost around $400, and it's going to let you do 1 million reads and writes per second. And we have to find a way to translate that 4 terabytes into as many accounts as possible, and that 1 million read and write operations into as many transactions as possible. So what we're targeting is to have this hardware support several billion accounts and to support 25,000 transactions per second at a minimum. I think we're going to beat those numbers, but those are our performance targets. And the way that I look at it is every 10,000 transactions per second gives you space for a couple 100 million daily active users. So that's the kind of scale that we're talking about. And then you start to reach the limits of a single disk. So this is what we're building with NOMT, is just to make sure that the hub and other chains that use NOMT would be able to get as much out of the hardware as possible. Now, NOMT is not part of the hub as it's going to launch immediately, but we are talking and we're working closely with the team at Parity, which is in charge of the hub, and the team at Parity that are focusing on Substrate to create the option to use NOMT within Substrate. And that would be the way that NOMT would get used as part of the hub. Now, Substrate was created, and sorry if I'm going a little long here, but Substrate, we started building Substrate in 2017, and there's a lot of code. So to some degree, it's going to be a retrofitting process. It's going to be taking this new state-of-the-art database and making it work with an SDK that wasn't necessarily designed with NOMT in mind. But it can be done, and I think it's going to get most of the benefit from it. So it's an important piece of the puzzle when we're talking about the future vision of what the hub might be. So that you have a chain, just to fix the numbers and to be very concrete about the numbers, to have a chain that can support hundreds of millions of daily active users, to support at least 1 billion users in total, and to do that all with very modest hardware requirements that don't cost a lot of money, so that anybody can still run a node. And that will create a lot of breathing room for applications and users on the hub to grow, right, without being worried about reaching those scaling limits.
Yeah, I see. From the top-down approach, I think many developers also might wonder why they have to choose the NOM as the solutions for their underlying database over existing solutions that have in the market. So maybe we could start from the first principle approach a bit. So in the blockchain space, or even in your article, you mentioned about a lot about the state, right? So can you explain a bit about what is the state in the blockchain? Is this just a database record?
Yeah. Well, so you have a blockchain, and the blockchain, new blocks are added to it, and these blocks are making transactions. Those transactions affect account balances, they affect smart contracts that are stored, and that's what the state is. So you start from no state, or whatever the beginning state is, and then you add a block, and 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 with each block that state is changing, and it's growing. New users are joining, new smart contracts are deployed, new applications are created, and all of that is stored in what I call the state. What is canonically called the state. It's the result of all of the blocks that have happened so far. And you have to keep that on the node so that you can process future transactions, so that when you get the next block, you have the state that and the accounts that those transactions need. You have the smart contract code that those need. But we do something special in blockchains, which is, it's not just about keeping that data, it's about keeping it in a special format, which allows it to be used for interoperability. And I can leave that very high level for now without going into the details, but this is what we call a Merkle tree. So we organize the Merkle tree in a special format, the state into the special format known as the Merkle tree. And that allows the state to be bridged. You can send balances from one account to another without having to trust any third party. That's what the Merkle tree lets you do. So off-the-shelf databases, and there are many good ones. There are databases like one very popular one that many blockchains use called RocksDB. From Facebook, they wrote it. And then there's also LMDB. There's, I can name a few of them, but these things don't focus on this Merkle tree. So you can always do better with a specialized solution, and the overhead of dealing with the Merkle tree inside of those more general purpose databases is too high. It's very expensive. So we built something that focuses on the Merkle tree and on the blockchain use case to keep all of that data.
And what's the underlying database that you use? Like, if not like RockDBs or LMDB?
We have written everything from scratch, actually. So we are going way down to the lowest level and dealing with the operating system directly to manage the data on the hard drive, on the solid state drive.
And I remember like Parity, they also have a Parity DB that like built to replace like RockDB as well. So like are there any like, limitations in the Parity DB that you decided not to use it and then like, build something from scratch?
Yeah, I mean, there are a couple issues with the Parity DB. So Parity DB is actually pretty similar to some of the other general purpose databases that I mentioned. Not RocksDB, but another family. And I'll get into some tech details. So Parity DB is a general purpose database. So it doesn't do anything special with the Merkle tree. You still have to use it for the Merkle tree the same way that you would use RocksDB or the same way that you would use LMDB. So it's not going to be as fast as something specialized. The other thing is that we're making use of some new features in the Linux kernel. When I say new, I mean in operating system terms. Linux kernel moves very slowly. So I'm talking about using a feature that has existed since 2020, but it's starting to become more widely adopted. It's something called IOU ring. What IOU ring essentially lets you do is it lets you very efficiently do reads and writes to many different places at once. Whereas the traditional way of doing reads and writes from a disk only lets you do one at a time. And there's a lot more overhead. And the mechanism that Parity DB uses is one of those older mechanisms. And it uses a mechanism known as memory mapping. And there are a few issues with memory mapping. One is that you don't know when disk reads and writes are going to happen. So sometimes the data is in memory, sometimes it's on disk, and you have no transparency or visibility into when it's going to happen. And if you want to make things fast, you have to have control over exactly when reads and writes are going to happen. So memory mapping isn't as good for that. And just furthermore, it's not as optimized for parallelization as NOMT is. But it's a good database. It's just not making the same use of newer technologies as we are.
I see. So, but like, is the Merkle tree required for the data layer of the blockchain? Like, are there any blockchain out there that doesn't use the Merkle tree?
Yeah, there are some examples of blockchains. So Bitcoin doesn't have a Merkle tree. That's the biggest example. And Bitcoin could use a Merkle tree for all what are known as UTXOs, which are essentially their way of storing the state of all accounts. But there's also Solana. And the main reason that like Solana doesn't use a Merkle tree is because they see it as something that's slower, that it adds a lot of overhead. So, with Solana, their goal was to get as fast as possible and get rid of a bunch of things that they felt were slowing them down. So they got rid of the Merkle tree. The reason Bitcoin doesn't have a Merkle tree is just because nobody had thought of it when Bitcoin was created. There were many conversations in the early Bitcoin talk forums. If you go back to like 2010, 2011, 2012, there were big conversations in the Bitcoin forums about adding a Merkle tree because it's really useful. Somebody can prove to you, for example, that you have some Bitcoins in a completely trustless way. Whereas in fact, now the way that we use Bitcoin, it doesn't work like that at all. Somebody has to, unless you're running a full node, somebody has to tell you whether and which Bitcoins you own or not. And the main benefit of the Merkle tree is that it's useful for bridging and for trustless reading of the state. So you may notice that there is no trustless bridge out of Solana. And in fact, it's impossible to create a totally trustless bridge out of Solana because it's impossible to create a small proof that an account exists on Solana. It's impossible to create a small proof that an account has certain tokens on Solana. It can only be shown if you run a full node, and that's because they don't use a Merkle tree. So I would argue that like having a Merkle tree is very much more useful for decentralization and for trustless bridging than not having a Merkle tree, even though it adds some overhead.
As you mentioned about the bridging solutions, that the Merkle tree is also like part of it. If like norms is implemented for like one blockchain, does it also like require all the blockchain to implement norms?
Sorry, could you repeat the last part of your question?
Yeah, I mean like if there are two blockchain like A and B, does like it's a requirement that like A and B required to use like norm as the underlying Merkle data store?
Do you mean if A and B communicate, do both of them have to use
like
NOMT?
chain A and B, chain A and communicate with chain B, this require like norm to be used for like both chain A and B for like a secure, trustless like bridging solution.
No, it's not required. They can each use their own format, and actually Merkle trees, there's many different kinds of Merkle trees. So you have the one from Ethereum called the Merkle Patricia tree, I believe invented by Gav. And then you have you have many other variants as well. There's lots of research on it. It's not required that blockchains use the same format, but they do need to understand the format that the other one uses. That's actually much easier than implementing a database that actually stores the stuff in this format. But they do need to understand the format that the other uses.
Okay. So with norm, like are there any like current limitation that your team are facing right now and you are trying to solve?
Nothing at the moment. I think the biggest limitations are finding what the correct set of features to add is to make sure that it can be as widely used as possible and as useful as possible for as many people. So understanding exactly which features should be present and which ones shouldn't be. And there's some future stuff too. So one of the limitations that we're currently dealing with is that we don't support arbitrary length keys, so that the keys are always expected to be 32-byte strings. But it can be useful to have longer keys. Some of the other things that we're looking into are, for example, what does NOMT look like when a computer has multiple drives, not just one? So we talked about having a single high-end SSD, which would be 4 terabytes, and it would give you 1 million operations per second. Well, if you had a second one, then you have 8 terabytes, and you have 2 million operations per second. If you had 3, you have 12 terabytes and 3 million operations per second. So how do we actually, in the future, how do you make even better use of the hardware so that you can split across many drives to store even more accounts and have even higher throughput? Those are research problems that we're looking into. But as far as it relates to like the 1.0 and the immediate future, we don't have any major engineering challenges.
Is SSD the only options that the database can write to, or it cannot just write to the disk?
Sorry, could you repeat that?
I mean, like, is SSD is the only option that the database like can use, or it can just use like disk as like default option or something? Yeah, sorry, like, because I haven't dived deep into that part much.
Yeah. When I say SSD, I do mean the disk. It's just a particular category of disk. So, previously we had hard drives, right? We had the spinning disk hard drives, and they actually spun. And the new ones are pretty fast. They often spin at 7,200 rotations per minute. So it's very fast to spin, but it's still much, much slower than the solid state drives. And, what you have in your phone, what you have in your laptop is most likely a solid state drive. So it's a different technology, but it still serves the same purpose of, reading and writing and keeping data persistent, right? So when you shut off your phone or you shut off your laptop or you shut off your server, that the data is still there when you turn it back on. But different technologies have different properties. So one thing that SSDs are really good at with comparison to hard drives is that an SSD is really good at reading and writing many things at once in parallel. So I can say, okay, read something from here, read something from here, read something from here, read something from here, and then get all of the results back. Whereas with a hard drive, if I want to do multiple reads, I have to wait for it to spin here, read that, spin here, read that, spin here, read that, so on. So it's basically the same thing. It's just that we are relying on certain properties that hardware would have.
Let's talk about like the iteration. So you mentioned like NOM going to be the implement for SIP3 soon, maybe like in the near future. So do you have any, like, aside from SIP3, like, do you have any plan to integrate that with other blockchain?
Yeah, there are a few. So there's the Sovereign SDK. They're building a rollup SDK, and they're actually the ones who came up with some of the original ideas in NOMT's architecture. So I got to know them about a year ago, and they really wanted NOMT, for their own chains. So they're going to be integrating that. We're talking to a few other people who are building rollups and things like that. Other SDK developers, for example, and yeah, and then plus substrate. So our goal with NOMT is for it to be as widely used as possible, right? Like this is a public good. It's important in open source software to create something that can be used by anybody, and this is the state database right now is the bottleneck, the biggest bottleneck, aside from maybe ZK proving, in the entire blockchain space. So everybody needs this. If you talk to blockchain node developers and you ask them what's stopping you from making your chain faster, they will tell you it's because the state database is too slow. So everybody needs this, and I think it's very important for that to, to be built and to drive the entire space forward.
What's the benchmarking result of NOM right now, like compared with other existing solutions? Like, do you have the number?
Yeah, I can tell you what we've recorded so far. So we've recorded on a database with 128 million accounts, doing over 40,000 transactions per second. And that includes collecting Merkle proofs, which adds some overhead. Beyond that, we have even more. So I think like we are looking at 40,000, potentially 40,000. Now our target, and I don't want to deviate away from this too much, and I will have concrete numbers when we do our next official round of benchmarking, but our target is to have 1 billion accounts and to support 25,000 transactions per second. But it will be faster with smaller databases. So if you only have 10 million accounts, if you only have 20 million or 50 million, it's going to be much faster than that even.
So let's say like if SIP3 already like integrate norms and like replace the existing solution, integrate NOM, there's like all the parachains have to rerun their benchmarking on the palette they already written. Yeah.
Yeah.
Okay, I see. So is
but
it yeah.
Oh, go ahead.
Yeah, I mean, like, so is the requirement that like all the Paragin team or the Polkadot SDK based blockchain have to rerun the benchmarking on the pallet?
Yes, if they are switching to NOMT, they would have to update their fees and their weights for the chain, very much in the direction of making things cheaper rather than more expensive. So, hopefully it means free transactions or near free transactions on every single substrate chain that adopts NOMT, at least until there are several 100 million daily users on a chain. But yes, if they adopt NOMT, they would have to rerun the benchmarking.
The full name of NOM is nearly optimal. So I wonder like, why it's nearly optimal, but not like fully optimal.
Yeah, we have some ideas about that. What the next versions could hold. I don't think NOMT is perfect. I don't think NOMT nearly optimal Merkle tree is the final form. I have some ideas about like new data structures that could be even better for space as well as performance, but we'll have to see. Maybe we'll just decide that what we have now is good and then rename it.
Yeah, awesome. So yeah, so I think that also like pretty much about NOM and like very details and maybe about like your upcoming plans. Yeah, so I think you mentioned it, right?
Yeah, we have some plans. I mean, we want to release the 1.0 version, and then talk to users and focus on integrations. So once it's released and once it's stable, we want to get it integrated into as many blockchains as possible, in order to make sure that everybody gets the benefit.
So there's a few comment on Discord. What you're building now, but I think like we already like answered this. So what was the thinking behind supporting EVM? I think like from my perspective, like NOM is basically just an underlying data layer that agnostic to the chain, right? It doesn't limit to any kind of blockchain. Am I right?
Yeah, that's right. As well with, I think they might mean the for the Polkadot Hub, and in the Polkadot Hub, it's the main thinking behind supporting EVM is that it's the most widely adopted smart contract language. So you have the best tooling, you have the best block explorers, you have the most developers. And to be honest, it doesn't matter that much which language you use, right? You want something that's developers like, that's important. And EVM isn't perfect by any means, but having strong EVM and MetaMask support is going to create the largest network effect. So most people use MetaMask, they use Ledger. Developers are going to use tools like Remix and Truffle and Foundry. And it's very important that they have the ability to work in the languages that they're most familiar with, as well as, the way that like business development often works in the blockchain world, especially for layer 1 blockchains, is you have these big applications, like let's say Aave, for example, and they have EVM code already. And you want to talk to Aave, right? Because they have a big borrow and lending platform on Ethereum and on many other chains. But Aave is a big player, right? Like, and they, it's much easier to make a deal with them, for example, to deploy EVM code onto Polkadot than to say, hey, we have a new language, it's even better, right? Like, and maybe it is. But it's much easier to get them to deploy when there's EVM. But Polkadot Hub is not only supporting EVM. So Polkadot Hub is using sort of a bytecode, as we'd call it, this PolkaVM. And then we've created I say we, but the team at Parity has created a compiler that translates EVM bytecode into this PolkaVM bytecode. So for a developer, it feels almost exactly the same. For the user, it feels almost exactly the same. You just use MetaMask, you just take the Solidity code that you're familiar with, and you can compile it into PolkaVM. But it also creates space for new languages to emerge. So I think this is very important. It's not that we're just using EVM and saying we stick to the EVM because it's good. We say EVM is the best thing right now. It has the biggest network effect, it has the most developers, it has the best tooling, and it has the most established apps. But there may be better languages in the future. It may be possible to write something with Rust. It may be possible to write something in some new language hasn't even been invented yet. So it's very important to support the future as well. So that's the smart contract design of the hub.
Polkadot Hub with NOMT, do you expect like it's gonna be faster than Ethereum rollup?
It depends which rollup. I think I'm one.
Maybe like the fastest rollup right now. I don't know like what's the name of it. Base, I guess.
Yeah, I think it'll be faster. I mean, the thing with rollups, many rollups, is that they have a single sequencer, right? So they're not really decentralized. They have one sequencer that's a node that creates blocks. And this is pretty beefy node. Usually it's got a lot of hardware, and they usually have a lot of RAM, right? And what they do oftentimes is they load all of the state into RAM. And you have to have gigabytes and gigabytes of RAM, maybe even terabytes of RAM. And then they're really fast because all of the data is in RAM. So it's hard to compete with something which loads it in RAM, but it will be fast. I think that performance is not as important as state size. And I think that this is a trade-off that the industry is making badly right now. So is NOMT going to be as fast as Mega ETH? No, but it's going to be in the same ballpark. Instead of 100,000 transactions per second, it's going to be 25,000 transactions per second. But we're going to support way more accounts. We're going to support way more users. And if I had to choose between something which can do 25,000 transactions per second and support 5 billion accounts versus something that can do 100,000 transactions and has one node and has a ZK proving bill of $1 million every day or whatever it is, it's millions every year that they want to spend on ZK proving. I would always take the one that can have more accounts and a little less throughput. And this is the trade-off that I think is important to make in the long term, because you want everybody in the world to be able to use it. And most of the applications that we develop right now, if you're a blockchain developer, you look at state, creating a smart contract storage, creating account as something expensive. And so what do we do when this becomes free, or close to free? What do we do when blockchains states become abundant? What are things that you can build when you're not worried about avoiding storing things on chain because it's expensive and limited? I think that this is going to open up new territory.
So if I understand correctly, right now, Polkadot asks the user have to deposit some dot to secure the storage store on the chain, right? So if with this migration, do we expect that these deposit can be removed, and then they can easily just submit a transaction and without paying the fee for the storage?
Yeah, I believe that Polkadot chains that are using NOMT should be able to lower these deposits to almost nothing safely, and even change to a system which doesn't require these deposits unless the state is filling up very, very fast. And I've written a little bit about that. There's an issue in the fellowship RFCs where I outlined some issues with the existential deposit system. In my opinion, we should give state away for free until it becomes a problem. And if you think about having billions of possible accounts, then it should be free unless it starts filling up very, very quickly. And then it should be charged for. And you can design mechanisms that do this. So the short answer is yes. I think existential deposits, once a larger state stops making things slow, should go much, much cheaper.
Yeah, I remember back in like 2021 when like the Persian Oceans hit its hype, and then like to create one account on Polkadot, it cost you like $10 or something.
I think even more than that, because it's a one dot existential deposit, and the peak price of dot was $50, right? So people had to lock $50 in their account. So it was, I think, really difficult and very painful experience for many people. So making state cheap should avoid this completely. But I think it's important, right, to note something, right? Like the intention behind the existential deposit is to make sure that you don't reach the limit of accounts too quickly, or nobody spams it. And Ethereum is a good example of what happens if you don't have this kind of limitation. So in Ethereum, there is no existential deposit. You don't have to pay any state rent. On Solana, you have state rent, for example. It's low. It's not that low, but it's much lower than on Polkadot currently. But in Ethereum, you don't have any state rent, right? So you can have an account with like nothing, 0.000001 ETH. And so there's no limitation. There's no economic tie between the amount of accounts and the amount of fees or the amount of tokens in circulation or anything like that. So that's the real reason Ethereum L1 is slow, because they have to slow down the chain to stop people from creating new accounts and creating new pieces of state. So you have to have some kind of mechanism for people to pay for state, but otherwise you have to slow down the chain artificially to stop people from using it. You have to ration block space. So, there's a happy